collector current IC, and the output voltage will be VCB. Output voltage will be VCB. And you tell what is V1, V2, I1, I2, I1 and I2. What is V1? V1 is the input current, input voltage, I1 is the input current. V2 is the output voltage, I2 is the output current. So you tell what is V1? V1 is equal to
VB.
VBE. I1 is IE. V2 VCB. I2 IC. So far you have identified the terminal voltages and currents in common base. Next we will write, you need to first write those two equations, V1, I2. If you don't remember suddenly, then you can start with I2. Recollecting the working of transistor, that output current is dependent on the input current and output voltage. Input current and output voltage. You can remember this thing, I2. Function of I1 comma V2. Right? So next, H11, H12, H21, H22. So many times I am writing for your sake. I don't know how many you are writing in the notes simultaneously along with me. Now, one more exercise is H11, H12, H21, H22. What is H11? What is H11? What it represents? H11. Using equation 1, what we have written H11? H11 is V1 by I1 with V2 equal to 0. కావాలంటే మళ్ళీ చూపిస్తాను. I will show you here. See here from the two equations, these are the two equations. So H11, we have written it as V1 by I1, input impedance. So this you will get only when you set V2 equal to 0. And H12, H12, V1 by V2, what we need to set 0. Yes, I1 0. So like that we have defined all the 4 H parameters. So here we have defined, right? V1 by I1 from the equations only. మీరు డౌట్ కూడా అడగట్లేదు, ఆన్సర్ కూడా చెప్పట్లేదు. మరి వింటున్నారా, వినట్లేదా, అర్థమవుతుందా, అర్థం కావట్లేదా? ఐఎమ్ నాట్ గెట్. If you have any doubt, then I will clarify. You simply keep quiet, then I cannot say anything. How would I know if you don't ask anything? Input impedance HI, forward reverse voltage gain HR. రివర్స్ అని ఎందుకన్నా మళ్ళీ మళ్ళీ రాస్తున్నాను నేను. V1 by V2, V2 by V1 ఉంటే గెయిన్ అనేవాళ్ళం. Now it is V1 by V2. So H11 is input impedance we are calling. So V by I. Beginning only I have written V by I impedance. Input. So V1 by I1. And H1 to H21 forward current gain. Current gain is output current by input current. And H22 output admittance. Admittance we are right saying. So I by V. Output we are saying. So I2 V2. V2. So this is H forward, HF, output HO. Now, since we are drawing the H parameter, we are writing the equations for common base. We are writing H parameter equations for common base, and we are drawing the model for common base. I am going to add a second subscript HIB, HRB, HFB, HOB. to indicate that these are the H parameters of common base. To denote that these are the H parameters of common base. Now what I will do, the same equations now, this 1 and 2, 1 comma 2 are rewritten with respect to common base, are rewritten as V1 means VBE, I1 means IE, V2 VCB, I2 IC, this is anyhow IE VCB. Now H parameters we will replace. H11, what is H11? Input impedance of common base. So HIB, HRB, one second. Madam class లో one second. చెప్పండి. అదే నేను అటెండెన్స్ ఫాలో అప్ చేస్తున్నాను. వచ్చినట్టుగా మ్యాపింగ్ సెంటర్ నేను లేదు కదా. వచ్చేసింది, మీరు అప్పుడే పంపించండి. మ్యాపింగ్స్ సిలబస్ రెడీగానే ఉన్నాయి. అప్పుడే మనం బిఫోర్ ఏది మంజులాగా ఇయర్ ఏం కాదు మేడం, కోడ్ అనుకున్నాం కానీ అదే కోడ్ కరెక్ట్ కదా ఇప్పుడు. సో మనకేం పెండింగ్ ఏం లేవు. ఇప్పటి వరకు అయితే ఓకే. అటెండెన్స్ సిగ్నల్స్ పీడీసీ వచ్చింది మేడం. పీడీసీ ల్యాబ్, పీడీసీ సిగ్నల్స్ వచ్చినట్టున్నాయి. ఇది ల్యాబ్ వచ్చింది, నాది అయిపోయింది. మిగిలినవి రావాలి. నేను మళ్ళీ చెప్పాను మేడం క్లాస్ మ్యాపింగ్స్. సరే ఓకే, మీకు మెసేజ్ పెడతా. ఓకే సరే. So these are the two equations pertaining to the common base configuration. Now these are the two equations of common base configuration. So HFB and HOB. Now how to draw the model? So model is very same. Model is similar to the previous one. The model and the components are same, right? So here HI, a voltage source, HRB, VCB, so this is the input voltage VBE. So you can easily remember that this is the first term and this is the voltage source. So applying KVL to the input loop, you will get first equation. Like that you can remember. Input current is IE. And coming to the output circuit, the collector current IC is the sum of the current 1 by HOB if this is VCB, then this is collector current, not this one. This is not the collector current, this is collector current. So current through this branch is HOB into VCB and current through this branch is HFB into IE. So applying KCL at this node, we will get second equation. Applying KVL to the input loop, we will get first equation. This is the H parameter model of common base. So H parameter model of common base. So very important model of common base. So similarly, you can draw the H parameter model for common emitter and common collector. If you have any doubt, please let me know. Okay then. So I will show you here the common emitter and common collector. So common emitter. See here, common emitter. The emitter is grounded, therefore base and emitter will become the input terminals. Collector and emitter will become the output terminals. We know very well, we have practiced many times while discussing the input and output characteristics, right? So common emitter, and the potential difference between base and emitter is VBE. Now this will become the input voltage V1, and base current will become the input current I1, and VCE will become the output voltage V2, and IC will become the output current I2. So draw the configuration first with the transistor symbol. With the transistor symbol, draw the transistor configuration. Okay. Next, find out what is I1, I2, V1, V2. So you need to draw the circuit, draw configuration. Second, identify V1, I1, V1, I2, V2. Third, write H parameter equations. Write H parameter equations of the considered configuration and draw the draw H parameter model. So like that, if you practice, then once you become perfect, you can directly draw the last H parameter model. But don't practice the last model directly. So if you follow these steps, then you will get perfect in drawing the H parameter. So same components are same. The resistor will be there, HI. I will redraw in the same uh, circuit. I will redraw for common emitter. How easy you only will observe. Just I am removing this. All of you see here, earlier we have written here in place of HIB. Now we are going to write HIE, and here HRE, and here HOE, and here HFE, and based on the input and output currents, this will become base current. This is anyhow collector current. This will be the HR into V2, right? So this is VCE because this is VCE, and this is IB. Now this is the common emitter model, CE model. So ultimately, these two equations, this is general model. This is the general model where I1 V2 I2 V2 I1 I2 V1 V2. It is the model is drawn in terms of I1 I2 and V1 V2. Okay. So this you need to remember. If you can remember these two, then it is going to be very easy. So you can draw directly this circuit. Later you can change it to whichever configuration we are trying to draw. So that you can write. If suppose common collector, then I will write HIC. Then I will write here HOC. I will change it to HFC. I will change it to HRC. All the four H parameters. Later, if I by drawing the common collector is grounded. So this is base and this is emitter, common collector. So in common collector, input current is IB, VCB, VCE, and IE. So what you can do, first you draw the circuit, later you erase these components and you can write in place of I1, write IB, in place of I2, write IE, in place of V2, write VCE, in place of V1, write VCB. And in place of wherever V2 is there, VCE. And I1 is there, so this is IB. So like that. So remember these general equations and general model. Remember general equations in terms of H1 and 2 suffix and remember this model in terms of the I1, I2, V1, V2. Later you can modify it to the transistor currents and transistor voltages. So this is drawing the H parameter model for common emitter, common base and common collector. Very important for 2 marks, draw the H parameter model of common any configuration. They may ask any configuration. They may ask any configuration. And this model, this H parameter model is called as exact H parameter. There are two types of H parameter models. Exact H parameter model. Exact H parameter model and approximate H parameter model. Exact model is there and approximate model is there. Exact H parameter model and approximate H parameter model. So what the difference between exact model and H parameter model is that the model or the circuit model or circuit includes all the four H parameters. It includes all the four H parameters. Whereas here includes only two. Two will be neglected. Includes only this model includes only two H parameters. So remember, identify carefully whether the question is uh, given to analyze using exact model or approximate model. So approximate model means these four components will not be there. 1, 2, 3, 4, 4. So all these four will be there in the exact model, whereas all these four will be there in the exact model, whereas only two will be there in the approximate model. Only two will be there in the approximate model. So this won't be there in the approximate model and this won't be there in the approximate model. Only these two will be left. So this is approximate model. So whatever we are right now discussing, this circuit, it is called exact H parameter model. Now we will do the general analysis of transistor amplifier. Now we will analysis of transistor amplifier. To obtain current gain, voltage gain, input impedance, output impedance. of amplifier of amplifier in terms of transistor H parameters. All of you see here the typical values of H parameters for common base, common emitter, and common collector. This is common collector. We observe the HI, the input impedance of common emitter, input impedance of common collector, input impedance of common base. HR, reverse transfer ratio of common emitter, common collector, common base. HF, the current gain, which is nothing but beta. If you recollect, HF is 50. If beta is 50 for common emitter, for common collector it is beta plus 1. So minus 51 minus 0.98. We know that this is alpha, right? Which is approximately unity. So HF is nothing but current gain. HF is nothing but current gain of the transistor. HF is nothing but current gain of the transistor. So we know that current gain of common emitter is beta. Current gain of common collector is beta plus, this is gamma, which is equal to beta plus 1. And current gain of common base is alpha. So we know alpha is approximately 1. So HFB for common base is 0.18. This is 50 minus 51. So this minus indicates that there is a phase difference of 180 degree between the input and output signal. The minus denoting there, the minus indicates that there is a phase difference of 180 degree between input and output. And these are the output impedances of common base, common emitter, and common. So with these values, we can observe that so it means HI now make it clear that all of you please see if this is a transistor. BJT, I2, I1, V1, V2. So BJT could be in CB, CV, or CC in any configuration. So this is transistor configuration, which is acting like a two-port network. Now, how to form an amplifier? So an amplifier is formed, if you remember, to the left of this, across the input terminals, if you apply a signal source, AC source across the input terminals, and if you connect a load resistor across the output terminals, now this will become the amplifier. Now this is the transistor amplifier. This is the transistor amplifier. The current through RL is IL. To the transistor configuration, if you connect a source at the input and if you connect a load at the output, then transistor amplifier can be formed. Suppose this BJT is in common base, assume. Then this is the common base amplifier circuit. So if BJT is in common emitter, then that will become the common emitter amplifier. If BJT is in common collector configuration, after connecting the source and the load, that will become the common collector amplifier. Now, the parameters of BJT, now the device parameters, the device parameters of BJT are HI, HR, HF and H0. So this HI, HR, HF, H0, these are the transistor parameters. HR, HF, H0 are transistor parameters. These are transistor parameters. It means if you take HI, you take HI value, these values are fixed for each configuration. I have shown you the tabular column, the typical values of each parameters, right? So those are fixed for each configuration because they are device parameters. What is the input impedance offered by a transistor in common base, that will be fixed, and that those values will be provided by the manufacturer when you buy component. Data sheet will be provided by the manufacturer, which includes the H parameters of the transistor, all the H parameters of the transistor. That is, it includes the H parameters of common base configuration. It will give you the H parameters of common collector and common emitter. So these are fixed. So here HI is the input impedance. Let us say HI is the input impedance of transistor. HI is the input impedance of transistor, and whereas ZI or RI is the input impedance of amplifier. It is the input impedance of amplifier. So there will be a slight variation between the input impedance of the transistor and amplifier, because HI is the input impedance of the transistor configuration, and input impedance of the amplifier is going to be different from HIE, because this RS and RL may affect due to RS and RL, because of RS and RL, because of RS and RL which are connected externally, the input impedance, the ZI or RI, will be different from HI. Different from HI. So HI అనేది ఇన్పుట్ ఇంపెడెన్స్ ఆఫ్ ది ట్రాన్సిస్టర్ అవుతుంది, and RI or ZI is the input impedance of the amplifier. And similarly, I will write here AI. What is HF? Can anyone tell? HF. HF, what it denotes? HF. వినట్లేదైతే ఎవరు క్లాస్లో? ఇంకెవరు వినట్లేదైతే? కరెంట్ గెయిన్ ఆఫ్ amplifier or transistor? HF.
Transistor.
H parameters are the parameters of the device of the transistor, whereas AI is the, what is AI? Whereas AI is, what is AI? Current gain.
Current gain of amplifier.
Amplifier. Why why transistor current gain and amplifier current gain are not same? Means because of the externally connected source and load, this RS and RL will slightly change the voltage gain or current gain transistor uh, compared with the current gain of the amplifier. There is a slight difference between these two. So our intention is similarly HO is the output impedance, output admittance of transistor, transistor, whereas here R naught is the output impedance of amplifier. And what is left? HR. HR. If you find out 1 by HR, this is the voltage gain of transistor, and this is, whereas here VAV, voltage gain of amplifier. So make it clear that H parameters are the parameters of the transistor, they are not the parameters of the amplifier, gain of amplifier. Now, if you look at the circuit, whatever the block I have represented for BJT, internally this block will be replaced with, this will be replaced with H parameter model. This will be replaced with H parameter model. Now, once we replace the BJT with H parameter model, you have to calculate, you have to derive, the expression for current gain, voltage gain, input impedance, output impedance of amplifier in terms of, because the circuit contains H parameters, RS and RL. So the circuit contains H parameters, RS and RL. So it means you need to derive AI as a function of RS, RL, H parameters. So you need to find the current gain of amplifier in terms of H parameters of the transistor. So in the I have IT class, I could not adjust it. I thought of to take continuously till 12:40, but I will take it to 12:40 again. Again I will take it 12:40. I will end here. I have to engage the IT class. So once again you join the class at 12:40. I thought of to take continuously, but I could not adjust that IT class. So now in the next class, very important, we are going to derive the amplifier current gain in terms of H parameters, amplifier voltage gain, amplifier input impedance, amplifier output impedance. Here this is the, so this is the same circuit I have drawn. Now this, whatever the transistor block is there, now it is replaced with H parameter model. So using this circuit, we are going to find the current gain AI, RI, voltage gain, output impedance of the amplifier. So like this. So this kind of equations we are going to find. So current gain of the amplifier in terms of circuit elements. So circuit లో ఏమున్నాయి, H parameters ఉన్నాయి, రెండు resistors ఉన్నాయి. So this you need to derive the expression till we arrive this kind of equations. Voltage V1లు, I1లు, V2లు, I2లు ఉండకూడదు final equation. So till that we need to simplify. అదే ఇన్పుట్ ఇంపెడెన్స్ అనుకోండి, దిస్ ఇస్ ది ఇన్పుట్ ఇంపెడెన్స్. సో ఆల్ వాట్ ఇఫ్ యూ అబ్జర్వ్ దిస్ సర్క్యూట్ డయాగ్రామ్, if you observe this circuit diagram, you need to find the, whenever we are trying to find the expression of voltage gain, current gain or anything, that expression should involve only these components, RL, not I1, I2, V1, only circuit components must be there in the expression. So we will continue at 12:40, you can leave now.